All right. So, these are Mr. Perkins' shortcut rules for drawing polyatomic ions as Lewis structures. And these work almost all of the time. These aren't really the rules. That's why you'll never see this as an ed puzzle, right? These are just make it as easy as possible, get almost everyone right, high school chemistry rules, all right? So let me be real clear on that. Everything I teach you in this class is rock solid, except for this. So if you go and say, well, my high school teacher said the college professor will be, well, that's not correct. Well, I'm going ahead and telling you now, right now. These are shortcut rules. They work most of the time. I will also make sure I only give you questions that these work on, all right? So here's what we do. When we draw polyatomic ions, all right, number one, we place the central atom and the peripheral atoms in a bracket. All right? You go ahead and you write the charge outside the bracket. And if you don't know what the formula is, you just look it up. All of the polyatomic ions that we use are given, and they're all on page 7 on your reference tables, right? Okay? So number one, you put the central atom and you surround it by the correct number of peripheral atoms. Let's do carbonate, all right? So if you didn't know what carbonate was, you would look it up on page 7 and you'd see that it was CO3 negative 2. Everybody agree that's carbonate? All right, so you place the central atom, boom. Then you go like this, put a bracket. Then now, how many oxygens do we need? 3. All right, so we're going to write an oxygen here, an oxygen here, and an oxygen here. All right? So this, and then we're going to write up here, negative 2. So this is the first step. Okay? Step number 2. Step number 2. Give everybody one line. Boop, boop, boop. And this is going to set us up for a really simple math exercise. No. Really simple. All right, look. Here's what we do. For carbon, right? We look at carbon. How many lines does carbon want to make? 4. That's exactly right. If you at home don't know why carbon wants 4 lines, because it's in group 4, and we drew the lines on top of the periodic table, it wants to make 4. All right? So carbon wants to make 4, but how many does it have here? 1, 2, 3. Everybody see that? So carbon, we would say, it's at a -1 right here. Don't write that down yet. Don't write it down yet. If every line just had 1, wouldn't carbon be missing 1? Because it's only got 3. It wants to have 4. Carbon's missing 1. And then let's look at oxygen. Every oxygen wants to have how many? 2. But we're missing 1 here, we're missing 1 here, and we're missing 1 here. So oxygen would be at -3. What's -1 minus 3? -4. Is this a -4 charge? No. It's a -2 charge. So let's add another line. What if I put a double line right here? Now we'll start our math over again. Okay? Let's look at carbon. How many lines does carbon want to have? 4. Now it's got 1, 2, 3, 4. Carbon is even. Carbon is happy. Everybody agree with that? So carbon is at 0. It's happy. How many lines does every oxygen want to have? 2. But there's one missing there, and there's one missing there. So oxygen's at -2. What's the charge here? This is carbonate. Now you just add the dots that you need. This has got 2, 4. So now we need 1, 2, 3, 4. This has only got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Does that make sense? After you figure out the number of lines you need to draw in the middle, just slap on your valence, your unbound pairs of valence electrons. Just try another one. Try another one. All right. Here we go. Let's try. We're going to do the same rules. We're going to try nitrate. All right. We look it up. Nitrate is NO3 -1. Everybody agree with that? So I'm going to write an N in the middle. And we'll put 3 O's around it. I'm going to put a bracket right here. I'm going to write -1. Okay? Everybody can get this far? All right? All right. Let's give everybody a line. Boom, boom, boom. Everybody see that? So this is our first guess. Okay? How many lines does nitrogen want to have, Caroline? 3. So nitrogen has 3 right here, doesn't it? 1, 2, 3. So nitrogen we would say is even. Nitrogen's at 0. How about oxygen? So this is just the number 0. How about oxygen? How many lines does every oxygen want to have? 2. But we're missing one. There, there, and there. So nitrogen's at -3. Is this a -3? No. So this isn't right. What should we do? We should go back in and be like, well, that doesn't work. All right? Well, let's add a line. I'll just put it right here. It doesn't matter where you put the other line. Okay? Now let's try it. How many lines does nitrogen want to make? 3. But how many does it have? 4. 1, 2, 3, 4. So nitrogen has +1. What about oxygen? Oxygen wants to have 2. That one's happy. But there's 1, 2 missing. So for oxygen, write -2. What's +1 minus 2? -1. And this is -1. That's it. That's what nitrogen looks like. These are not the real rules. These are some shortcut rules. The real rules are more complicated. We don't have time to go into that. Yes?
Is that just showing us how, like, the atom looks?
Well, these are how the central atom is bonded.
Okay.
So, and then now we go back and we make everybody happy. So this is going to need 6 more dots, 3 unbound pairs, 3 unbound pairs, 2 unbound pairs. Done. That's what nitrate looks like. Does that make sense? All right. I'm going to put one more up here for the people at home. I'm going to ask you to do sulfate. And that's SO4 -2. I'm going to pause it for the people at home. Y'all do it. All right, so we would start off with an S with 4 O's around it. We would get everybody one line, and then we'd start doing our math. We'd say, oh, okay, we know very well that S only wants to make 2 lines, but it's got 4 lines, doesn't it? So S is at +2, and that O is missing. Every O wants to have 2 lines, So there's one missing. 1, 2, 3, 4. O is at -4. What's plus 2 minus 4? -2. And this thing has a -2 charge. So this is what it looks like. And then you just add your valence electrons. And this, y'all, is sulfate as a polyatomic ion. That's it. These are some pretty straightforward, simple rules. These do not work all the time. This is some jacked up stuff I made up to make your life as easy as possible. Okay? The real Vesper rules are more complicated. That's it.